Hello friends, this is Priyanka. Today we are going to solve a problem on load sharing between base load plant and peak load plant. In this video we are going to find out what is the minimum cost of generation in rupees per kilowatt hour. First I will read what is the given question. The annual load duration curve of a station varies uniformly from 64,000 kilowatt to 0. The load is supplied by two stations whose cost equations are given as C1 is equal to rupees 8,40,000 plus 840 kilowatt plus 0.116 kilowatt hour. C2 is equal to rupees 5 lakh plus 440 kilowatt plus 0.2985 kilowatt hour. Find the minimum cost of generation in rupees per kilowatt hour for the system. So this was the given question. Let us first understand what is the given data. It is given that the annual load duration curve varies uniformly from 64 megawatt to 0. That is, the maximum load for this load duration curve is 64 megawatt and minimum is 0. It is also given that the cost for the base load plant and peak load plant. So base load plant we will use here the suffix 1. So C1 is equal to rupees 8,40,000 plus 840 kilowatt plus 0.116 kilowatt hour. And C2 is equal to, so C2 is used for the peak load plant. So for peak load plant we will use here the suffix 2. It is rupees 5 lakh plus 440 kilowatt plus 0.2985 kilowatt hour. Now if we observe these costs, then these costs are divided into three parts. First part is the fixed part, that is here some fixed amount is given. Then the second part is for the installed capacity. So this installed capacity is for year. So it is given that the yearly cost, and that is also mentioned in the question. So this installed capacity cost. So installed capacity, that is nothing but in kilowatt, and this is the cost for the kilowatt for duration of year. Then the third part is for the energy generated. So whatever is energy generated in kilowatt hour, that cost includes in this third part, that is 0.116 and 0.2985 kilowatt hour. So here duration is for 1 hour, that is mentioned. So from this given cost we can say that here we will give the notation for the cost of the installed capacity and cost of the energy units generated. We will consider here the notation A for the installed capacity cost and notation B for this energy units generated cost. So for the peak load plant, here suffix 2 is used, and for the base load plant suffix 1 is used. So if we observe for the installed capacity cost, that is A1, that is equal to 840 and B1 is equal to 0.116. In the same way for the cost C2, that is for peak load plant, A2 is 440 and B2 0.2985. Now we will move to draw the load duration curve. So how to draw? The condition is given, it varies uniformly. Maximum limit and minimum limit is given, that is 64 to 0. Now here on this vertical line we will plot here the load, and we will take here load in megawatt. So here minimum is 0 and maximum is 64. And on the horizontal line we will take here the time and time in hours. Now the cost mentioned is the yearly cost, so we will take the number of hours in 1 year. So number of hours in 1 year, that is equal to 8760. So from this 0 to maximum limit 8760. Now at this 0 load, here this is the, here starting point is 0 and end point is number of hours in 1 year, that is 8760. Now this load duration curve varies uniformly from 64 to 0. So we will join this, and here the total period 8760 hours is getting covered. here is the load duration curve. For economic load sharing, area under this load duration curve is divided into two parts by a horizontal line. So here is the horizontal line, and because of this horizontal line, this total area is divided in two parts. Now how to decide the magnitude for this horizontal line? If we observe, this line is parallel to this baseline and which is time in hours. So we can say that magnitude of this line L is also in hours. Now we have formula to calculate this, that is A1 minus A2 divided by B2 minus B1. So we will put the value 840 minus 440 divided by 0.2985 minus 0.116. So when we calculate this, we will get here 2190 hours. Now if I extend this line, that is this point of intersection on this baseline, then this magnitude is 2190 hours. So I will show this. Now we will give here the notations for this triangle. So here this point is A, then here I will say this is B, C, and here D, E. Now if we observe, here is the triangle ABC and here is the triangle ADE. Now we have to decide what is the peak load on the peak load plant and what is the peak load on the base load plant. So I will show here what is the peak load on base load plant. So I will give here the notation is PB, that is peak load on base load plant, and PP is nothing but peak load on peak load plant. Now we will show this in this diagram. So because this is the horizontal line, and because of this line there is the economic load sharing between base load and peak load plant. So I will show here this vertical line distance, that is nothing but PB, that is the peak load on base load plant, and above that here this is nothing but PP, that is the peak load on peak load plant. Now we have to decide this PP and PP. So how to decide? So for that we will consider two triangles, that is from triangle ABC and from triangle ADE. Now we will take the ratio. So ratio of sets. So suppose if I take this ratio, that is in triangle ABC, if I take the ratio, that is AB and AD, that is AB divided by AD is equal to, now we will take the ratio for this base of these two triangles, that is BC divided by DE, which is equal to BC divided by DE. Now we will put the value. So what is the value of AB? So AB is nothing but PP, that is the peak load on peak load plant, divided by AD. So A to D. So this vertical line is load is given in megawatt. So we will write here kilowatt because all the costs are given in kilowatt. So I will write here 64,000 kilowatt, which is equal to BC. So this BC is nothing but L and it is given in hours 2190 divided by DE, that is 8760. So when we solve this, we will get PP, therefore PP is equal to 16,000 kilowatt. Now we have to calculate PB. So from this diagram, if we observe, this whole vertical line is 64,000. Out of this PP is 16,000. So what is PB? So PB is 64,000 minus PP. That is 64,000 minus 16,000. So remaining is 48,000 kilowatt. Now we will calculate energy generated by the base load plant as well as peak load plant. So how to calculate the energy generated by base load plant? So it is nothing but the area under this BCEDB. So this whole area that we have to calculate. Now this area is the addition of two sections. So this first section is in the form of rectangle and the other section is in the form of triangle. So we have to add these two areas, that is this area 1 and area 2. So how to calculate the area for this rectangle? So this base multiplied by height, that is 2190 multiplied by height. So this height is nothing but this B to D. So this height is 48,000 kilowatt. So we will multiply here with 48,000 kilowatt. Plus, now this second is for triangle. So we know that how to calculate half multiplied by height multiplied by base. So half multiplied by height that is 48,000 multiplied by base. So what is this base? So it is 8760 minus 2190, that is 6570. Now we will calculate this. So if we observe, we can take here 48 into 10 raised to 3 as a common, then 2190 plus 6570 divided by 2, that is 3285. So we will solve this. Plus 2190 multiplied by 48. So it is 2628 into 10 raised to 2. So here 10 raised to 3 and 10 raised to 2. So I will write here as a 10 raised to 5. So here this is the answer. So what is the unit? So unit, if we observe, this load is taken in kilowatt and here this base is hour. So we will say that kilowatt hour. So this is the energy generated by the base load plant. Now in the same way we will calculate what is the energy generated by the peak load plant. So this is nothing but area for this triangle ABC, because this is the economic load sharing by this horizontal line. So area above this line is the load, that is the energy generated by the peak load plant. So we will take here area for this triangle, that is half multiplied by base. So base is 2190 multiplied by height. So height we have to take in kilowatt, that is 16,000. So we will solve this. 2190 divided by 2 multiplied by 16, that is 17520. So I will write here 175.2 multiplied by 10 raised to 2, and here is 10 raised to 3, that is multiplied by 10 raised to 5. So if we observe what is the unit, so same unit is there, that is kilowatt hour. Now we will find out what is the total energy generated. So total energy generated, that means this total area. So we can add all these areas, that is section 1, section 2 plus this triangle. So we will add these two areas, total energy generated, that is 175.2 plus 2628, that is 2803.2 multiplied by 10 raised to 5. So here we will take 10 raised to 5 as a common and unit will be kilowatt hour. So this is the total energy generated. Now we will calculate the cost for the base load plant as well as peak load plant. So base load plant suffix 1 is used. So C1 is equal to, so as per the data we have to add the cost for the installed capacity as well as cost for the energy units generated. So first part is the fixed part. So we will take here 8,40,000 as it is plus 840 multiplied by, now we have to take kilowatt. Kilowatt, that means installed capacity. So if we observe for the base load plant here, this is the installed capacity in kilowatt, because there kilowatt is mentioned, so we have to take in kilowatt. So it is 48,000 kilowatt. So we will multiply here with 48,000 plus, 0.116 kilowatt hour. So kilowatt hour is nothing but the energy generated. So if we observe for the base load plant, energy generated is 2628 into 10 raised to 5 kilowatt hour. So same unit that we have to use. So 2628 into 10 raised to 5. So when we solve this, we will get 792.1 into 10 raised to 5. So this is the cost. So unit is rupees. Then we will move for the second. So C2 is equal to 5 lakh is the fixed part. So we will take as it is plus 440 multiplied by kilowatt. So this kilowatt is nothing but installed capacity. So it is 16. So if we observe in this diagram, it is 16 megawatt, but we have to take in kilowatt. So we will multiply here with 16,000 plus 0.2985 multiplied by, we have to take kilowatt hour, that is the energy generated, that is 175.2 into 10 raised to 5. So when we solve this, we will get 127.7 into 10 raised to 5. So what is the total cost? That is C1 plus C2, that is equal to 919.8 into 10 raised to 5. Now what is the question? Question is that we have to find out what is the generating cost in rupees per kilowatt hour. So if we observe, this is the total energy, here this is the total energy generated, and here is the total cost, and we have to find out for 1 kilowatt hour what is the cost. So when we take this total cost divided by this total energy generated, then we will get the cost for 1 kilowatt hour. That is 919.8 into 10 raised to 5 divided by 2803.2 into 10 raised to 5. So which is equal to rupees 0.33 per kilowatt hour. So here is the answer.